So, good morning and welcome to the second day. We have 4 blocks today, 4 blocks of approximately 1 hour, an hour and a half. And for each of these blocks, I will give a presentation, and you will have a small assignment to work on to understand the structure of the assignment, but the real assignment work will be homework. So we need to do something afterwards. I would like you to be in groups of 2 people or 3 people. We'll see whether some more people will join today. But nevertheless, I'll explain how it works, and we can still form the group then later today. Bonjour. Yesterday we talked about, or we had more the perspective of the hacker. So this was important to understand which elements or which way of thinking is necessary for you as a developer to think of. So, and one major skill you should be able to develop, or you should develop over time, actually, is that that as a hacker you need to think like a developer. You need to think what the developer might have done or might have thought when developing a specific element to get in. Now we turn this around now. Now it's the other way around. We need, as a developer, if you want to develop secure applications, exactly to turn this around and to think as a hacker. So we will actually enhance security, software engineering capabilities, software engineering practices with specific security elements that should help you in thinking like a hacker, so that you prevent certain attack types. And that's the overall goal of today. So what can be added to the different elements in a software engineering process so that you can make sure that security will be attained. Okay? So, and we have 4 blocks. The first block today is about methodologies and requirements. So we will review in the first step the software engineering methodologies and how the security activities fit into there, and which of these methodologies contain already some practices, and what are available best practices for secure software engineering. And then we will look more specifically into the requirements gathering process for security. The second module then later this morning, would then be on threat modeling. We will do some threat modeling exercises. Have you already done threat modeling? Okay. We will review that, and we will look at design flaws and how to to address them with security principles and security patterns. The afternoon we will look at coding and testing. That will be rather a short thing, since you already talked about the OWASP top 10. But we will emphasize a little bit on how to code, and we will pick up the acceptance criteria from requirements engineering. And the last session will be on deployment. So once the software is basically ready from the developer's point of view, there are still a number of activities that need to be done afterwards to run it securely. So this is the program for today. I will see how far we go. Yeah, that's the agenda. You know the structure is simple, and I go through the different points over time. As a first disclaimer, so to say, secure software is not achieved only by using cryptography. So it's not, I need to encrypt something and then I'm secure, or by using standard security tools like firewalls and antivirus, or by employing people with security clearance, so having someone in your development team that knows security doesn't help the others to develop securely just because he's there, or by using some weird operating system that nobody knows. So in a long period of time, the SAP developers thought they don't need to do anything about security because SAP, nobody knows the operating system of SAP, so why should I care?
Payment. It's not here. Sorry.
No problem. We changed rooms, so probably this will happen a number of times. So, and indeed, and this is, from a today's perspective, you would say, how can this be? But indeed, for as long as I was there, until maybe 2007, at SAP, developers thought, actually, nobody knows the ins and outs of SAP's operating system and of the application platform, so we don't care. Okay, perfect. Good. So, but what do we need for actually create secure software? Secure software is software applications that are secure against hackers, more or less, right? And you need actually to integrate, this is my experience, and this is also what the great practitioners tell, it needs to be integrated in every phase of the software lifecycle. So it's like a chain with lots of links, and the weakest link will break the chain. And the weakest link could be in requirements, you're forgetting requirements, so you're not looking at specific stakeholders, for example, or you're in development, you're not paying attention to good coding, or in deployment, you're not configuring the system right when setting it up. So each of those elements can actually break the security of your system. So the importance is you need to integrate it into the whole software development lifecycle. And there's one saying, there's a standard approach in many small software organizations is called penetrate and patch. Penetrate and patch describes the following approach. Every time I'm releasing software, I'm giving software to the customer, I'm going to have a penetration test before delivering this. So I give someone the task, please test my application. If you don't find anything, I consider it to be secure. And if you're not, then I'm going to patch my system. And that's it. And then I deliver it to the customer. What's the problem with this approach? Well, you will only find those things that this one hacker or this one penetration tester is able to find. So it's limited to his scope. It's his perspective. And that's a big risk. Moreover, you need not only to actually think about being the software being of good quality in terms of security, you also need to think about potential intruders that come into your development organization. So if something is really interesting for, say, organized crime, like, say, à la bourse, it may well be interesting to send intruders into these development teams to build backdoors in. So you need to think about that process as well. So we will focus, of course, on the best practices, assuming there is no intruder, but just for the picture to be complete, you also need to think about this type of attack, where someone joins the development team with bad intentions. Quelqu'un qui va essayer de faire de mauvaises affaires déjà dans l'environnement de développement. Therefore, you need a secure developing environment. So you need to set up your development infrastructure in a secure way, because you could hack this. You maybe also need a secure physical environment so that nobody gets in. A secure operating environment, of course. Maybe also secure hardware, and maybe also personal security. So this is just to complete the picture. We will not talk about this much, but just to be sure, these are things. If you are working in a sensitive environment, this should be addressed as well. And many organizations today are giving this responsibility to small suppliers, so small specialized software development organizations, teams of 20 people, 50, 25 people, 15 people, doing special development for applications. But they often don't have the capabilities of the security like a large organization has. So they're often very risky. Bonjour. So this is often pretty risky for sensitive applications, for example, une bourse or an energy provider, to let their critical applications or applications that may be connected to critical applications be developed by small SMEs, because they don't often have the skills or the capabilities to do this. So as someone who is in charge of the security, maybe you won't develop software later on, maybe you're sitting on the demand side, so you actually are giving the task to other companies to develop software for you, so you're basically reduced to the requirements engineering phase. Then you should know this as well. So this is not limited to developers. Is it working? So again, the major sentence here is the, in most cases, used approach, penetrate and patch, does not work, because you need to think about more elements than just this. So we won't take these 4 or 5 here more into account, but you need to have additional processes and maybe also additional security-focused activities in the software development lifecycle. And we will look at these in more detail today. So we will give you the software development lifecycle models, and we will shortly discuss how they differ and in which way they are relevant or helpful in terms of security. For all software development lifecycle models, you have these 5 activities. Whether you're doing a waterfall model, or an agile approach, or even DevOps, you always need to analyze requirements, to think about design or architecture, you need to implement, you need to test, and you need to deploy or to maintain. So these 5 classes or these 5 groups of activities are necessary for each software development model. And we therefore will think about where to put security in these different 5 activities. So, for example, if you're looking at an agile model, requirements engineering is explicitly addressed by the product owner. Let's say we take Scrum as a methodology. The product owner typically thinks about functional requirements and creates backlog items for the functional requirements. He should, for security, add backlog items for security requirements. So you need the same model, you use the same model, but the requirement engineer / product owner needs to add the security requirements to that model. It's not going to work by magic, just by telling developers, now do it securely. You need to explicitly describe this. In a waterfall model, it's clear, you do this from the beginning. So let's review them shortly. The classical waterfall model with this type of steps here, requirements, analysis, design, coding, testing, and deployment. This is, I would say, only done in very, very small projects now, or maybe in state projects. Sometimes state organizations still demand a very structured linear process, like the V model, for example, V model XT, which is waterfall-like. But you still have the chance, and there's one security approach following this model. We will see later, and we still have the chance here to review in one phase. The problem, of course, is if you discover something in testing, like this arrow shows, that shows up some design problems. In the classical waterfall model, you're not allowed to change anymore. So you need to stick with this. So you document the weakness, and you cannot really do anything about this. So I would say this is a very costly approach, and often not very good for security. You could have prototyping models, or you need rapid application development, or a spiral model, or extreme programming, or a very structured model. For each of those, you don't need to read all the slides. For each of those, you have these standard phases: requirement analysis, design, coding, testing, delivery, and maintenance. And you need to add specific security elements, or you can formulate it also the following way. Each of these phases must be suited to produce secure software. For each of these phases, you may have different risks. So the first one, actually introducing such a thing, was Microsoft. By saying, okay, we have these different phases. Microsoft still follows a waterfall model. It's interesting to know, but they're doing waterfall. SAP does Scrum now since 8 years internally, but Microsoft does still waterfall. And they integrated, as you can see here, the different touch points. They've integrated additional activities into the development program, into their activities. And they call this, since they don't have any other non-functional requirements they're looking at, specifically like security, they call it the SDLC, the Secure Development Lifecycle. That's from Microsoft. It's Microsoft invention, so to say. In the software industry, SDLC in general means software development lifecycle. But in Microsoft's context, it says as secure. And you can see here some first additions to the development, to the standard development. There are additional activities that are considered as touch points. So in specific points in time during the development, you would add specific additional activities. That's the Microsoft approach. It has been written up by Gary McGraw, who was responsible for secure development at Microsoft in 2001 and on in March 2004 in his book. But this is basically a Microsoft invention of 2001 period. And you see, they started with abuse cases. We will refine this concept of abuse cases in the threat modeling approach. This is a more structured approach for creating abuse cases. So abuse cases are use cases you don't want to happen. So use cases are scenarios or elements you would like to implement with your software, you would support with your software that you're going to develop. Abuse cases just the other way around, software that you don't, use cases you don't want to have. Additional security requirements to explicitly then perform at a pretty early stage some risk analysis, so to consider some risks. We will integrate this into the threat modeling. You will see how this works. Then they've integrated an external review, so someone external to the team should actually look at the software and maybe just see things that if you're working day to day with specific aspects you won't see. They would do some, they would write test plans, and this is something a good thing. They write test plans well before coding, and they add risk-based security tests here. Furthermore, they have added static analysis tools to coding. So they've actually Visual C, the Visual C development environment currently has a number of security analytics tools integrated into the compiler. So if you start the compiler, then and you don't turn this off, then you would also perform security tests by default today when working with Microsoft Visual C, the Visual C environment. Again, risk analysis at the end for the test results. So which of the test results are the most critical ones, which one should be addressed, and they've integrated penetration testing and additional security breaks later on. So this was kind of a very early approach in industry to create secure software. It was the first one basically. So what do we do in the different phases? I will quickly go through these different phases as a kind of an overview of what we're going to do in detail of the rest of the day. You need to formulate security requirements. And here on this slide, this is divided into explicit security requirements and implicit security requirements. Explicit security requirements are requirements that have a documented customer demand, where the customer says, I want this and this to be part of the solution, or it is a compliance requirement, where if you want to implement a solution in a specific market, say medicine technology or IT in the healthcare environment, you have to comply with specific additional rules, so you need to add them to your solution, so they're explicit. Or you need to comply with certain certification processes because the customer wants a certificate for his solution. Yeah, there are also implicit security requirements, which are typically non-functional requirements. Actually, now this is not really functional and non-functional, but this is to a large extent in the past, the explicit security requirements were functional requirements. Now more and more people start to understand that for making software secure, it's not enough to have a security feature. We need to have additional requirements that in some way express the resistibility against hackers, for example. How can I describe this? Just because if I'm integrating with a firewall, it doesn't mean actually that it's going to be secure against hackers, right? So this is something we need to deal with, and therefore, this probably you know how to deal with. As if you have an IT or a software engineering license, this is something, well, someone will tell you. You will look up what it means. You will deduce what it means for your application, and from there you will know what to code. But this is more difficult. This is the area where you do not really exactly know which security requirements are meant. This is the area where your customer says, if you ask him, and do you have any requirements regarding security? And he would say, well, nothing explicit, but I want it to be secure. And you say, okay, so what does that mean? What does that mean? So this is really the difficult part in the requirements phase, namely to find out what security capabilities your system should have to fulfill the needs of the customer. So first of all, this is something you need to argue with your customer. So is he going to be happy if the application withstands say an experienced hacker for an hour or for 3 days or forever? Something, and then you need to explain to him, well, if you want it to be secure for a day, then we probably need this and this and this and this and this, and the solution is going to be cost, I don't know, 100,000 more. Is going to be ready to pay for this? Is he so he needs to, if so in this case, your role as a development team, probably you're the product owner doing this, is to explain to the customer that security comes in different levels of quality, and these different levels of quality cost. Obviously, you cannot get security for free. You can get some basic security for free, maybe, but not good security. So if you really want an application to be able to withstand experienced hackers for a long period of time, long actually means more than a couple of hours, then this is not achieved by just doing standard stuff. Right? So, and therefore we need to understand what the potential abuse cases are, so the abuse cases as from a perspective of the customer. So the customer needs to formulate, probably you need to help him in doing this, but the customer needs to formulate his security requirements in terms of, I do not want certain things to happen. And that is going to help you then to deduce consequences for your architecture, consequences for your coding environment, and so on, for your operating system environment. And what we will use as a tool for you to use this, you can do it internally to the internal, of course, in the development team without any customer interaction, but this is, as explained, probably not as worthwhile, not as useful as if you would do it together with the customer. So doing it together with the customer, threat modeling, is actually the best thing you could do. Have a session with him. If he's concerned about security, have a session with him to get him to a level where he is able to formulate his abuse cases, and you are able to integrate this at a very early stage in your architecture. So that's threat modeling. There's some problems with security compared to other activities. Security is not composable. That means if you have two secure modules or two secure applications, and now you are going to combine them or you're going to integrate them, it does not mean that the overall new system is secure. So it's different from, say, performance. If you have performance in general is composable, so if you have two software components that have proven to have certain performance capabilities and you use them together, then the overall system in general, with small exceptions, will be very performant as well. It's not true here. You may have individual components that are secure in themselves, but as soon as you start integrating them, you may open up weaknesses, or you may have a design flaw that you add by this process. So of course it's important to use secure components if you're doing software reuse, but you need to think about to validate the security again for the overall system. It's not preserved under refinement, so it's the other way around. If your overall system is secure, and now that you have developed it last year, and now you think about, okay, for that project I could use that module I developed last year, now for my new project, doesn't mean that if this is secure, that the part you use is secure as well to use here. So that means for every system, obviously we need to look at the efforts, and it should be reasonable, but theoretically, for every system, you need to do a new security requirements analysis. It should be part of the normal analysis process. You should start with standard design architectures, and you should work in teams. Why should you work in teams? With maybe it's also an interesting information. You should work in teams because in teams you are much more creative than on your own. So interaction creates new ideas. So therefore, and as those that have been with me last year noticed. Therefore, I like to do these group exercises, because in these group exercises you get more ideas if you are just on your own. And here again, use this also as a capability later on in your practice. Don't work on your requirements document yourself on your own. That will be okay, I'm sure, but it will be far from the level of quality you would get if you were working in a team with where you have a small role play, and you start some creative interaction, standing somewhere in a creative corner and writing on a wall or something. Right? It's different. Secure design. So what can we do in the design phase? Obviously, you should follow security principles. You could think about security architectures. We will specifically look at trust boundaries. Trust boundaries are, say, virtual boundaries of software components within your architecture, where you would say anything within that boundary is trusted. So if a communication comes from here to there, I would trust that. Whereas when a communication comes from the outside, I won't trust it. Remember yesterday, don't trust user input. This is one element or one aspect of this. So users are always outside of the trust boundary. But even within your application, you may actually consider different trusts areas which are distinguished by trust boundaries. Typically, in a web application setup, you would have something on the web server and you would have something in the backend, and you would have a trust boundary between the web server and the backend, because you won't trust by default everything that comes from the web server, as you don't trust everything that comes from the user. But we will refine this later today. The goal of the secure design is, in general, to minimize the attack surface. So, the attack surface is a term. It's a picture. So you think about your application as being a sphere, for example, and every connectivity element to your application is something on the attack surface where the attacker could access the application. The more elements you have to connect to your system, the larger the attack surface is. And one goal is to minimize the attack surface so that if an attacker accesses it, you know that it can only happen here. If you don't think about this, it could happen here, there. One consequence of this approach is you shouldn't distinguish access for admins and users. So you shouldn't have another, like we had it yesterday, you shouldn't have another admin interface than the user interface. They should log in for the same procedure, and depending on their role, they will have then different functionalities they see. But there's no admin login, right? This is something we should try to avoid. And of course, threat modeling is in this phase. in that phase. Then we look at security practices during development, how to mitigate vulnerabilities. We will specifically look at a number of coding principles, let's call it. There are 4 or 5, depending on the way we address it. And these 4 or 5 coding principles, I think I already spoke about that yesterday. These will help you to code securely. You don't need to understand these different activities and all the actual information that is available for every programming language, and there's a new security programming guide for Python, and there's a new thing for Node.js, whatever. I would recommend you to get a little bit more abstract and to think about 4 or 5 principles you need always to have in mind when you code. Then it's independent of the programming language how this is actually resolved. Of course, some programming languages make things easier than others. So Java, for example, makes it very hard to create memory vulnerabilities, but not impossible. So you may, of course, think more about specific aspects with specific programming languages, but in general, I would say thinking about the programming principles is more helpful. Obviously, again, here, pair programming is a very helpful approach. Pair programming, you know what pair programming is? Pair programming is an approach, and this is used in very experienced development organizations, often larger ones, but also small ones which exist for a number of years now, and have some sensitive customers. Pair programming is an approach where you develop as a pair. So there's always 2 developers sitting in front of one computer, and only one coding. One is coding, the other is looking at what he's doing, and trying to help him, trying to find weaknesses. It also helps in terms of potential intruders. So spies would be probably easier recognized in pair programming environments because you always need to have a second person besides you. And then you change roles after 2 hours or so. So there's one is coding, and then you make a break for an hour, for an hour and a half. Then you make a break, and then you change roles, and you continue on the same subject. It very much helps in terms of security because you have 4 eyes, right? And the one is looking at this, and the other one is actually thinking about could that be, what could else happen. It's very helpful. You could, of course, then deploy and send out secure coding guidelines to the people so that they can work with this. You could perform manual code reviews, and as I shortly mentioned for Visual Studio, you could also apply tools in the coding phase for already identifying potential weaknesses in code. So there's a number of vendors actually offering code analysis tools. I will name a few. We will look in the internet later. Then testing. What needs to be done in testing? There's black box and white box testing. Black box testing is testing an application without knowing the ins and outs. That's what we did yesterday. Yesterday was black box testing. White box testing would have been if I would have given you the PHP file and the database schema. Using this, you would probably have been able to even detect much more vulnerabilities. Security software testing versus software security testing. Security software testing is testing the features like authentication, like encryption, whereas software security testing is testing for potential weaknesses. So it's not the same thing. just to keep in mind. It should be risk-based. Risk-based. Why risk-based? The assumption is always we will never be able to fix all vulnerabilities. There's much more that we can do. We'll never be able to be 100% secure. So we need to find a way of priority for the different things we do. And risk is, in the security arena, always a good approach for prioritization. And we will see an approach later. I will explain this in the threat modeling phase, so in the next block. You can create test cases from different elements. I will ask you to do some test case description for threat modeling results. Okay. Yeah, we will see this later. In the secure deployment phase, again, this is deployment is getting the software from the developer's computer into the operating environment where it's going to run. And there are a number of activities which are necessary to keep that secure. We will review these as well. And finally, if you're running security, if you're running software, or if it's out at customers, you send it out, they're using it on site, then still security weaknesses can occur, or in most cases, if your software is large enough and has enough instances in the world, then there will be security researchers or hackers trying to find weaknesses in your software, and sooner or later you will, as a developer, you will learn that someone has hacked your software, and then you need a way to respond to this. So what you will do about this, right? So can I fix it immediately? Oh, this is a design flow. I need half a year to fix that issue. This is a bigger thing. What do I tell the customer then? So how do I handle this? How do I communicate? Will I just tell nobody? I just fix it and issue a patch, or will I send it out just to my customers? Or do I know my customers? So if I don't know all of my customers, I need to make it public. Okay, so this is not trivial. So in the after development phase, so the major recommendation here is don't forget about security activities once your software is finished. All right, so you need to reserve some time or some resources for handling this in case something happens. Okay, now let's go into different security development models. The oldest one is the common criteria approach. Do you know common criteria? Can I say something? No, Nobel sounding. Common criteria is a harmonized approach of US, Canadian, and European standards in the 80s, 90s. So it's pretty old. It's a very, very formalized approach. So it very clearly describes what needs to be done to be able to be certified. You can actually get a certification for your product. Now it's an ISO standard. And the good thing about common criteria is that it has some generic set of security requirements. Good security requirements for good secure software. So you could pick these and use them in your requirements engineering phase, but the certification process in itself is rather difficult and rather hard. Common criteria is requested for software and tools by a number of states, organizations, specifically in the United States and in Germany as well. So for specific components like smart cards or firewalls it is necessary to have common criteria certifications to be able to be used in specific environments. In US, the US government requests a common criteria certification for all software used in the US administration with a lower evaluation level. I will not show you in a minute. But they need this. So this is even a market barrier. So it's difficult to get into specific markets if you don't have this type of certification. There are different levels and evaluation performance levels. So you formally work with security targets. So these are the goals, the security goals you want to achieve. The target evaluation, that's your software. So you can actually restrict the software to a certain feature set that needs to have some security functionalities. And you have the evaluation assurance level, which actually describes to which level the verification of your security has happened. So as you see from the model, the common criteria is more about proving a certain level of security than actually helping developers making something secure. So it's more the how can I check this instead of how can I make this. And the standard levels, so the one I just mentioned for the US, this is ERL3. So you don't need to have methodological development. So you don't need to prove logically that you develop everything according to your requirements, but you need to test it to verify it. And this is, and formally here, the higher level is really with mathematical formal verification proofs. So this is long period of time. You need to do this. And standard firewalls are here somewhere, 4, sometimes 5 for the higher level elements. The common criteria development model is a waterfall model. This is a bad picture I picked. This is from the specification document from common criteria. And as you can see, this is very waterfall-like. The problem is, or one of the drawbacks of common criteria is that you actually need to have a staged approach and to follow the waterfall process. So you need to finish the requirements documentation first before you actually can start with design. You can have a backflow, so you can change the requirements after having found things in the design phase. But indeed, in this case, you really need to work this out in this manner, which means this is an important standard in practice, although nobody likes it, which means that most organizations develop in an agile fashion, so they have an agile organization like Scrum for developing the software, but when they then need to get a certification, they write the documentation for the common criteria afterwards. So the software is finished, and then they start documenting the stuff for common criteria along the waterfall lines, which is obvious nonsense. I mean, this is meant to be done during development to make sure you do it the way they describe it, but nobody does it because it's much too expensive to integrate it into development in an agile fashion. It doesn't really work. So many people use this, but it's not really adequate for modern software development. The impact on the methodologies. Producers of the software must ensure the traceability of security feature implementations. It does not suggest a specific methodology, but since the approach for development, it's basically a fact that people do this, do the common criteria documentation as an aftermath. One problem is that common criteria is mainly about security features. So you cannot state something like my application is common criteria certified to withstand hacker attacks for 4 hours. That will not work. That's not possible with common criteria. But you can say something like the strength of authentication is high. The authentication strength is according to specific principles, and this is proven that you cannot bypass the authentication. This is something that common criteria is able to tell you. So as I said, common criteria does not lead to secure software. So some examples. So I already told this. Yeah. Some examples for common criteria certificates. I already mentioned the smart cards and firewalls in general. Microsoft certified Windows NT 351, so very old version of Windows NT. I think that was in the 2003 period, 2004, in that time frame somewhere. And Windows NT was certified without network connectivity. So the target evaluation, as I told you, was limited to a computer that has no network functionality, to prove that it's secure, it can securely be accessed, and that should probably, obviously, this would have been very difficult to be done with network connectivity, with all the network services on. So for the certification, Microsoft turned this off for the evaluation according to common criteria, which means as a result that common criteria, well, you really look into the certificate what's actually explained there. Another example, and I've been involved in that project on SAP side. I was the project sponsor for 2.5 years maybe. SAP, for entering the US American market in the administration, needed to have a common criteria certification for its product or products. We decided to certify the SAP basis, so the technology platform. Okay, how to restrict the target evaluation in such a way that the certification could be done in a reasonable amount of time, and so in such a way that the customer is going to be happy, US administration. We ended up by limiting the target evaluation to the authorization check routine. So within SAP, you probably know you need authorizations. Have you got some SAP courses? Yeah? Yeah. Okay. And if you're using transactions, then for executing transactions, you need a specific authorization or profile. And in the runtime, the profile is in a certain buffer of the user, and then when the transaction or the report is loaded, it will check whether the profile matches the demand. And this matching process, this was the target evaluation for the common criteria process. It took SAP 4.5 years to get this certified, and it cost more than 3 million euros. Why? What is the reason? What is the major reason? Common criteria assumes that software stays stable over the period of time of the evaluation. So as long as you evaluate, you have a stable version of the software. Nothing's changing. No requirements changing, no code changing, no system environment changing. SAP constantly, back at the time already, constantly changed their software on the go. So they needed to adapt new web technologies, they needed to integrate new interfaces. XML was big at that time, so there was always new functionality for XML integrated into transactions, and so on and so on and so on. So although the functionality in itself didn't change, the environment had changed. So those people that created the documentation for common criteria need to rework their documents every second month. Therefore, it took that long. So, summing up, COM criteria is the oldest approach for secure software. It is basically good in proving qualities of security features, like authentication, like encryption, like these things. It's not so good in proving that software is secure against hackers. It is therefore mainly useful for small devices with a clearly described set of functionalities like firewalls, like smart cards. So that obviously there the market is well evolving and still uses that approach, but it's not good for general software. Okay, so that's what we had in the 90s, early 2000. That was on the market. If you talked about software security, then everybody was pointing to that standard. But everyone who was experienced in the field said, it's not really helpful. So what do we do now? Where do we go? So, as I mentioned earlier already, Microsoft was the first kid on the block. So after, let me quickly check what is there. After COM criteria not being successful, and there was this in the 1999-2000, there was a big hype. This is long ago for you. Was a big hype towards internet. Everything should be internet ready. Everything should be able to connect to the internet. Today, this is trivial. Everybody does this. If you develop software, you immediately think about doing the cloud service. How do I set this up, and so on. That wasn't the case 20 years ago. But there were viruses in Microsoft software and worms that distributed among infrastructures by email or by network shares. And Microsoft was heavily criticized for not having security done ready. And Microsoft was therefore, and I will give you some details on the story, was therefore the first one actually promoting that we need something that assures secure software. Not so much for proving functionalities, but really in the way that we understand it today, namely that it's secure against hacking, secure against bad people doing things with that. And this is called SDL, Security Development Lifecycle, as I mentioned earlier. It's to reduce security-related design and coding defects and to reduce the severity of any prevailing defects. That's the first picture of the SDL, and it very much looks like this touchpoint thing. Obviously, it was the same two group of people working on this. So this is a more detailed approach related to this. Why the reason? I mentioned this already. In the early 2000s, Microsoft was put under heavy pressure due to the massive number of malware that spread using Microsoft technology. And the story is that the large US companies joined forces to attack Microsoft or to speak to Microsoft, and the saying is that they actually said, you better secure your platform or we will all switch to IBM OS2. And probably, and this is an operating you don't know anymore, right? Has anybody heard of you about OS2? OS2 was very successful in the banking sector, and was the probably much superior operating system over Microsoft in the late 1990s. It was very similar to the Mac operating system from the way it's built, but it was looking like Microsoft Windows. So kind of a best of both worlds back at the time. It was a Unix operating system beyond, and it had a look and feel like Microsoft did it. So this was very heavy pressure, because obviously if now Microsoft wouldn't do it right, the industry would say, okay, forget about Microsoft, we all go to IBM. In due course, Microsoft did it right and became, I must say, the best player regarding secure software development. He's still, so it's the most professional company. They've gone so far that they delayed one of their major products, namely Windows Vista, by 15 months. 15 months later, they delivered to the market because of remaining security issues during testing. So, and you imagine how much money that would have made for Microsoft to delay selling of a major product by 15 months. Yeah. Okay, and I would like to show you this memo. I will read it. It's very small. Can you read this? Well, so I let you read this. This is an email that Bill Gates sent out early 2001 simultaneously to all customers, partners, and employees at the same time. So there was no prior information to internal people before they actually sent this out to all customers and partners. Does he tell the member?
It was with the recording. No problem.
I've done some recording here, you won't see. The only thing is, I've uploaded the last one, I uploaded to SharePoint, but if you don't have SharePoint access, where can I publish it so that you can use it? What are you still using? Okay. Do you got groups at Google? Like, or I just publish it on my YouTube channel. Okay, I will do that. I will send you this. Yeah. You can just search for my name.
I searched you on LinkedIn.
I'm not on LinkedIn. LinkedIn is not very data privacy friendly. I'm on Xing, which is a German European portal to LinkedIn. XYNG. And I have a Twitter account. I have a Facebook user, but I'm not using it. I'm just using it for looking into Facebook. I'm not publishing it. Okay? 10 minutes?